Good evening, everybody. Thank you for being here. So for our project, we wanted to help radiologists to better detect breast cancer. We are Yolene, Edward, and Pauline. But why did we want to solve this problem? Well, did you know that in Belgium, more than 10% of the women are affected by breast cancer? I didn't know until last week. What I also learned is that what is key to cure breast cancer is to detect this as early as possible. To do this, a radiologist looked at a mammogram. Mammogram is just an X-ray scan of the breast. The first thing she does is looking and identifying the abnormality in the mammogram. It's defined by a region of interest. Secondly, the radiologist classifies the abnormality into a class. It can be malignant abnormality, meaning it's a dangerous tumor, or it can be a benign abnormality, which is not dangerous. In computer vision, these two steps are called image segmentation and image classification. So to solve this problem, we split it into two tasks. The first task is a segmentation task, and for this task, we use a deep learning model. So it might sound complicated, but it's not so complicated. A deep learning model is just a stack of layers of artificial neurons that you train with a lot of data so that this model can predict an output based on an input. So here, for the segmentation task, the input is the mammogram, and the output is a mask. It's just a black and white picture with the white pixels representing the area of the abnormality. For the second task, the classification task, we also used another deep learning model, this time to predict as output the class of the abnormality and as input the region where the abnormality is located. Okay, so now let's play the radiologist, and we'll use the app that we built during the last days. So the first thing I do is I select one mammogram, I upload it, I send it to the model, and we let the model do its job, meaning first predicting the region of interest where the abnormality is located, and secondly, the model will predict the class of this abnormality to see is it dangerous or not. Okay, so now we have the answer of the model, the prediction. So first thing that the model tells us is there is an abnormality on the mammogram. It's here. You can see the zoom here. Second thing it tells us is that it predicts that this abnormality is malignant. So it can be a very dangerous tumor. It predicts this with a probability of 71%. So what does it mean for the radiologist? It's not an exact science. It's just giving an indication that you should pay attention to this area because it might be very dangerous. So the radiologist will further analyze this and if needed, take further actions. So now let's try the model with another mammogram. So again, we upload the mammogram, the model process it, and predict if there is an abnormality first, and secondly, the model predicts if this abnormality is dangerous or not. Okay, so we have the prediction. So again, here the model predicted an abnormality somewhere here on the mammogram, and it predicts that this abnormality is benign, so not dangerous. But it also gave a probability. It's only 51%, which is quite low. So it means that for the radiologist, it should be okay, but you also need to check further if this is indeed benign. So what did we learn during the last 2 weeks, and if we wrap up our project? Well, first, for the segmentation task, our current version, the first version of the model, is able to detect one abnormality on a mammogram in about 30% of the case. It's okay, but of course it can be improved. And one step to improve this will be to use more data, more images with higher resolution. Because if you look at such a mammogram, it's quite hard to detect something. It's at least harder than in detecting a tomato or a pet on a picture. Something else we want also to improve with the model for the segmentation task is to train the model to detect more than one abnormality per mammogram. On the classification task, we had also to make a trade-off between the accuracy of the model, meaning how good is the model to predict correctly the class of the abnormality. And on the other hand, we also want, since we're playing with the people's health, we want also to be sure that the model is able to detect as often as possible malignant abnormalities. Something also else we would like to improve for the classification is to predict more information about the abnormality. So not only the class, benign or malignant, but also the type of abnormality. Last but not least, the last thing we would like to add to a model is a feedback loop, so that the model gets the feedback from the radiologist in order to improve the further prediction. So to conclude, the goal of our project is not to replace the radiologist, but to help to empower the radiologist to better detect breast cancer. Thank you very much.